Guys, this is a video about solving quadratic equations, which is a bit of a rerun from previous years. I've got three equations here, and there are several methods to solve them. First, we're going to look at factorization and using the null factor law. Then after that, we're going to look at complete the square on this difficult thing here. I'm going to skip use technology for now. But we're also going to quickly revise the quadratic formula on this one here. So let's start. 6x squared equals 11x plus 10. We're going to factorize the quadratic and use the null factor law. So to do that, I'm going to make sure that the right hand side is 0 first. So I'm going to make it 6x squared take 11x, take 10 equals 0. So the 11x and the 10 both move to the left. And then it's a matter of some experience and some looking at. But I know that a 6, I'm going to look at the term with x squared. The coefficient is 6, and a 6 can be made of 1 times 6 or 2 times 3. So I'm going to write, for memory, 1 times 6 and 2 times 3. And I'm also going to look at that 10, and the 10 can be made of 1 times 10 or 2 times 5. And those are all the options I have. Of course, it's a negative 10, so either the 1 or the 10 needs to be negative, and also or the 2 or the 5 needs to be negative in order to create a negative 10. Now it's a matter of combining those to get negative 11. We do that with the cross method. Now, I think looking at it from experience, because I've done this a couple of times, I have a good feeling about the 2 and the 3 and the 2 and the 5 to make 11. So 6x squared, I'm going to split that up in 2x and 3x. And that's where the cross method starts, the 2x and the 3x. And now I'm going to take the 2 and the 5 and realize, okay, if I do 3 times 5, I've got 15, and 2 times 2 is 4. And I can make a negative 11 with that, because if I have a negative 15 and a positive 4, I can make negative 11. That means the cross product here needs to be negative 15, so I'm going to put a negative 5 there and a 2 there. So the cross product is 3x times negative 5, that's negative 15x, and 2x times 2 is a positive 4x. Negative 15x plus 4x exactly makes that negative 11x. So now my cross product is complete. Suppose this doesn't work out, then of course I've chosen the wrong numbers, and I can change something. I can try it with 1x and 6x, or I can change it to a 1 and a 10 here. But one of these combinations must give the correct answer. So cross method, and now what I do is I read 2x take 5 as a factor, and the other factor is 3x plus 2 equals 0. If you quickly do FOIL on that, 2x times 3x is 6x squared, plus 4x take 15x makes negative 11x, and negative 5 times 2 makes negative 10. So this is the same as that, I'm pretty sure now. So now I can use the null factor law to solve this. 2x take 5 equals 0, or 3x plus 2 equals 0. 2x equals 5, x equals 5 over 2, or 3x equals negative 2, x equals negative 2 over 3. And there it is. The whole thing is solved. Now let's look at the next one. Negative 3x squared plus 12x plus 5 equals 0 already has a 0 on the right hand side, that's nice. I'm going to complete the square on this one, which is one of the most tricky techniques there are, probably there is. But you need to know this technique because sometimes in a question you need the vertex of a quadratic like this, and you need to find it algebraically, and that means you have to rewrite it in a certain format, in the x take h squared plus k format. And that's where completing the square comes in. So let's do this. First of all, I'm going to focus on these first two terms here, because that's where the completing the square is upon. And there's a common factor, so I'm going to take out that negative 3 there. In fact, what I'll do is I'll rewrite this, because I don't like the negative 3x squared plus 12x plus 5, the negative 3 bit, I don't like it. I'm going to make it, and then take 12x, take 5, equals 0. Now that is the same thing. I've multiplied both sides by negative 1. I can do that. So focusing on that first bit, I'm going to take out a 3 as a common factor and make it x squared take 4 x. And the negative 5 is just still there. Now what I will do is I'm going to complete the square on this bit here. Now complete the square, a perfect square would be x take 2 squared. So I'm going to write this as x take 2 squared. So you square root the first one, and you halve the coefficient of the second one, and then you square the whole thing. Now that has consequences, because this here, x take 2 in brackets squared, is not exactly the same as x squared take 4x, so we need to check that. This x take 2 in brackets squared is x squared, 2 times negative 2 times x, negative 4x, the double product, and the negative 2 squared is in there as well, which is plus 4. All of this is multiplied by the 3. Now, I had my x squared right there. I had my negative 4x right there, so that's all good. But this plus 4 here, I have now introduced like this by completing the square. So what I need to do is take that 4 away again. I've introduced it here, a plus 4, I'm going to take it away. But the 4 is multiplied by 3, so I need to take away 12. So I'm introducing a 4 in this bit. The 4 is multiplied by 3, that makes 12, and I'm taking it away here to undo it again. The negative 5, still there, I haven't touched it. So now I have completed the square. And this is the format. This is the completing the square all done. And now for a quadratic, I know what the vertex is. The vertex is 2, negative 17. That's the vertex of this quadratic. I also know that it's narrower than an ordinary x squared because it's 3 times. Because of the 3 here. That's something that we will learn in chapter 5 in transformations. So this has great value. You can see things. I now know what this quadratic looks like. Now to solve it, to find x, I just keep on going. I put the 17 on the other side and I'm going to divide by 3. So x take 2 squared equals 17 over 3. Now that means that x take 2 is plus or minus the root of 17 over 3. So I'm square rooting both sides. That means that x, well, take the negative 2 and put it on the other side. X is 2 plus or take the root of 17 over 3. Now that again gives me some insight, because now I know the vertex is at 2. I knew that all along from here. The x-coordinate of the vertex is 2. The y-coordinate of the vertex is negative 17. But I also know the roots of this equation. They are root 17 over 3 to the right of 2. I should point that way then. Yeah, there. That's right for you guys. And the other root is 2 take root 17 over 3. So that's to the left. So this thing is symmetrical. They are about x equals 2. This is the solution completing the square. It's tricky. Or at least I find it tricky. The last one is a lot easier, I hope. It's this one here, and we're going to use the quadratic formula. Now the quadratic formula, you know, if you would have this one, ax squared plus bx plus c equals 0, and you would solve this one by completing the square, and you can do that, what you get is the quadratic formula. You get the quadratic formula. The solution that you get is this: x equals negative b plus or take the root of b squared take 4ac over 2a. So by completing the square on this one here, for once and for all we solved it, and we found the quadratic formula, so now we can solve everything with that. In this case, a is a 2, b is a 3, c is a negative 6. So x is negative 3 plus or take the root of 9, b squared, 3 squared, take 4 times 2 times 6, and negative 6 actually, over 2 times 2. Now if you clean that up, this is going to be 9, this bit here is 48, 48 and 9 makes 57, so it's negative 3 plus or take the root of 57 all over 2 times 2, 4. There you go. A lot easier than completing the square, because this result here is already because of completing the square. It's the result of completing